Hello everyone. In this part of the chapter, we will learn about one of the most important theories in geography, that is plate tectonics. This chapter contains a world map showing the major tectonic plates and their directions of movement. Although these plates move only a few centimeters every year, their movement has completely changed the Earth's surface over millions of years. They are responsible for the formation of mountains, valleys, ocean basins, volcanoes, and earthquakes. By studying this map, we can understand why some places experience frequent natural disasters, while others remain comparatively stable. This map, shown in Figure 2.3, represents the Earth's major tectonic plates. Tectonic plates is a large, rigid piece of the Earth's lithosphere, which includes the crust and the uppermost part of the mantle. These plates are not fixed in one place. Instead, they slowly move over the semi-molten layer of the mantle called asthenosphere. This movement is driven by the heat inside the Earth, which creates convection current in the mantle. Although the movement is extremely slow, about 2 or 10 centimeters in a year, it has a huge impact over millions of years. The arrows on the map indicates the direction in which each plate is moving. The map shown tells us 7 major tectonic plates. The Pacific plate is the largest tectonic plate on the earth and it lies mostly beneath the Pacific Ocean. Because it is surrounded by several plate boundaries, this plate experiences frequent earthquakes and volcanic eruptions. The North American plate carries most of the North America and extends beneath part of the Atlantic and Arctic Ocean. The South American plate contains the continent of the South America and stretches into the Atlantic Ocean. Along its western edge, where it meets the Nazca plate, and Andes Mountains were formed through plate collision. The African plate includes the entire African continent along with parts of the Atlantic and Indian Ocean. It is slowly moving and is associated with the East African Rift Valley, where the continent is gradually splitting apart. The Eurasian plate covers Europe and a major part of Asia. It is one of the largest continental plates and has played an important role in the formation of mountain ranges. The Indo-Australian plates includes India, Australia, and the surrounding Indian Ocean. Millions of years ago, and the Indian plates drifted northwards and collided with the Eurasian plates. This powerful collision folded the Earth's crust and gave rise to the magnificent Himalayas. Even today, this collision continued, causing the Himalayas to rise slowly and making the Himalayas region prone to the earthquakes. The Atlantic plate supports the continents of Antarctica and surrounding Southern Ocean. Apart from these major plates, there are many minor plates and that also contribute to the geological activities. The arrows shown on the map are very important because they represent the direction of plates' movements. Plates do not all move in the same way. Some plates move towards each other, some move away from each other, and others slide horizontally past each other. These different types of movement create different landforms and natural phenomena. When two continental plates collide, they push the land upwards to form fold mountains like the Himalayas. When an oceanic plate collides with a continental plate, the denser oceanic plates sinks beneath the continental plates in a process called subduction. This process creates deep ocean trenches and volcanic mountain ranges. When plates move from each other away, magma rises from inside the earth and forms new crust, creating mid-ocean ridges. When plates slide past one another, the friction between them causes earthquakes. The green activity box titled Let's Map. This map carefully identify the continents and ocean associated with different tectonic plates. For example, the North American plate is associated with the continents of North America and the Atlantic Ocean, while the African plate is associated with the continent of Africa and both the Atlantic and Indian Ocean. This activity helps students connect physical geography and the concept of plate tectonics and improves the map reading skills. This activity explains that plate tectonics plays a major role in shaping the Earth's surface. Every mountain, valleys, ocean basins, and volcanic regions is directly or indirectly connected to the movement of tectonic plates. Plate tectonics also explains why continents are located where they are today. Scientists believe that millions of years ago, all the continents were joined together in a single subcontinent called Pangaea. Due to continuous plate movement, this giant landmass gradually broke apart and the continents slowly drifted to the present position. This process is called continental drift, and it continues even today. The textbook further explains that most earthquakes and volcanoes occur along plate boundaries. Plate boundaries are the regions where two tectonic plates meet. As the plates move, enormous pressure builds up along these boundaries. When the accumulated pressure is suddenly released, the earth shakes, producing an earthquake. In places where magma rises through cracks in the earth's crust, volcanic eruptions occur. Therefore, areas located near plate boundaries are much more likely to experience these natural disasters than areas located in the middle of tectonic plates. A very important region mentioned in this page is the Ring of Fire. The Ring of Fire is a horseshoe-shaped belt surrounding the Pacific Ocean. It is known as the most active earthquake and volcanic zone in the world. Around 75% of the world's active volcanoes and nearly 90% of all earthquakes occur in this region. Countries such as Japan, Indonesia, and Philippines, New Zealand, Chile, Peru, Mexico, and the United States, and Canada lies within the Ring of Fire. These countries frequently experience earthquakes, volcanic eruption, and sometimes tsunami because many tectonic plates meet around the Pacific Ocean. The blue activity box titled Let's Explore, it asks to compare the plate map with the earthquake and volcano map given on the next page. By comparing these two maps, you will notice that the regions with the higher number of earthquakes and volcanoes are located along plate boundaries. This observation provides strong evidence that plate movement is main cause of these natural events. Such activities help students develop observation skills and understand geographical concepts through maps. It emphasizes the importance of the theories of tectonic. It states that Earth's surface is constantly changing due to the continuous movement of the tectonic plates.